Good evening once again, everyone, and hope everyone is safe. Uh, Welcome to today's webinar on Anyone Can Learn Data Science, Democratizing Data Science. This webinar will be conducted by Mr. Mohan. Let me quickly introduce Mr. Mohan. He is the head technology programs at Times Group. Uh, he has done his BTech from IIT Kharagpur, the 1990 batch. Overall experience-wise, Mr. Mohan has an industry experience of 30 years. He's been an entrepreneur, co-founder at TrendWise Analytics. He's been a former vice president at SAP Labs. He's also an organizer of Bangalore Artificial Intelligence Meetup Group. And from technical skills, uh, he is well versed with artificial intelligence, machine learning, deep learning, TensorFlow, Python, and technologies around it. I'll let Mr. Mohan take over this webinar. Mr. Mohan?
Yes, Kaustav, thank you. Thank you so much for the introduction.
Yeah.
Good afternoon, everyone. Once again, welcome to the session. Appreciate you all take time on a Saturday afternoon. So this session is about data science, democratizing data science, and this is in association with Intel, our partner, and hence powered by Intel. I know probably this is a mixed audience. Some of you are already familiar with what data science is, and maybe some of you are working in data science area, and some of you probably are new and want to. Reason you are in this call is to understand what data science is all about and whether it is for you or not. So I'll try to keep it as much as possible in such a way that everybody gains or takes away something out of here. These are some of the key takeaways. The session is around helping us understand um, in terms of is data science for anyone, or are there any restrictions in terms of wanting to learn data science? And then I'll also talk about what it takes to learn data science, maybe a few things to, in case you are not yet started, how to get started, some of the data science jargon, and of course some of the tools and platforms, so that if some of you are new, you will at least familiarize yourself with some of the tools and the jargon and so on. And then I'll also touch upon the Intel One API kit. Intel is doing a lot around AI and data science. I will touch upon what is the Intel One API platform and so on. So that's primarily how the session is structured. Overall, it should take probably 30 to 40 minutes as a part of the session, and maybe 10-15 minutes for Q&A. I usually would like to keep my session interactive. So if possible, just shoot your questions in the chat box, and I will either take it up right away, or if some of the questions will be answered as a part of the session, I will hold off, but I'll make sure that everybody's question is answered, so we can actually keep the session interactive. And likewise, I might ask you a question, feel free to respond, so that will also help in keeping the session interactive. And also, to break monotony, it is not only uh, this is not only PowerPoint, but I will intersperse this with a video. At least one video is there, and then one or two demos, and so on, right? So the whole idea is to keep it interactive and engaging, rather than just boring one-sided talk. So the question from Bharat is, can you share this video about DS? Yeah, so I think this will be after the session is over. A recording will be shared, and if you want, you can. I think that's what you're asking about, or you're asking about. Um, okay, So yeah, I'm assuming you're asking about, or if you're asking about the video that I'm going to show you, that also I'll share. It's a YouTube video, so I will. It's available on YouTube. Okay, so with that, let's get started. So as I just want to reiterate, there are some questions. Just feel free to respond, or if you have any questions, just you can keep them coming. So recently, I came across this article on KD Nugget's website, and somebody has written, "Don't democratize data science." Right? And needless to say, and not surprisingly, a lot of people slammed him. Right? You see some of the messages here saying, it is because you want to be an elitist and you don't want others to learn data science. And then there was one more saying here that, looks like you don't come from, you only have a bachelor's degree, something like that. Not nice things, but a lot of people have, written some of the stuff which probably the author wouldn't like. But in all fairness to him, I think there is some point in what he is saying, right? So, though it doesn't sound very positive, so I would like to also give you a little bit of a viewpoint in from where he is coming from. But before that, is this? Do you agree with this? So that is my first question to you. Do you agree that we shouldn't democratize data science? Now, what is basically democratizing data science is that we shouldn't allow anybody to learn data science. We shouldn't open it up. We should. So data science should be restricted to only a few chosen ones. That's what he's saying. So my first question to you is, do you agree? Just want to understand if there are some people who agree to this, and there's nothing wrong, by the way. Don't feel shy, right? Sometimes we don't like to go against the popular perception, so we feel shy to talk about it. So excellent. So some of you have responded, and in fact, there are three responses, four responses, and everyone says no, right? You don't agree with this. Narendra Singh, Rikin, Prince, Vishal. So all of you are saying you don't agree with this, right? So fair enough. I think that's a fair statement or viewpoint. Then there was a couple of years back, there was another article, and this one, Harvard Business Review. Some of you must be familiar, a very popular journal. And there's an author by the name Jonathan. He said democratization of data science, and he was talking about, and our topic today is about democratization of data science. So the question is, why at all this debate? I mean, why should even somebody think about? It's like saying, education in general, right? So if somebody says education should not be provided to everybody, um, uh, does it make sense? So that's the kind of, but there must be some reason for that. Now, you can always say that a particular degree cannot be given to everybody or something like that. But in general, if you're talking about something like education and you say education should not be provided to everyone, so that's the point here. And why at all this debate? I think the actual issue is about, you see here they're talking about data science, and also the topic is around data scientists, to be more specific. Not and if you read the article also, he's talking about a certain function of data science, and that is basically the term data scientist. And I think that is where the problem is. The phrase data scientist is probably today the most abused phrase, I would say, in the world, right? Everybody talks about this, and any WhatsApp group, even WhatsApp groups, people talk about data scientists and so on, right? And that is basically is what is causing this debate. And this term itself is means different things to different people, and that is basically the reason for some of this debate. It's like people, blindfolded people, trying to find out what is an elephant. And this may be a little cliched. Some of you would have already heard about this, right? So if they go about touching an elephant, somebody touches the trunk and he says, "Oh, okay, elephant looks like a snake." Somebody touches the leg and he or she says, "Oh, it's like a tree." And so on, right? And somebody on the top you see is touching the ears and he says, "Oh, it's like an elephant is like a fan." So it is somewhat like that. The term data scientist is not very well defined, and what is the function of a data scientist, and what exactly is a data scientist? I think that is where some of this debate stems from. So who is a data scientist? Unfortunately, there are in some of these areas, these are first of all evolving areas. Data science is still evolving, and there is no one particular organization or entity which controls the terms and terminologies and designations and so on. So people come up with their own definitions. But by far the most common I have seen, most popular in a way, definition given is by these three circles. So somebody put together these circles saying, okay, a data scientist is somebody who does software engineering, who knows maths and stats and also algorithms, and he should be good at data communication, and blah, blah, blah. And then the intersection of all these skills is a data scientist. Well, you know what? That is a mythical beast. Such a person doesn't exist. That's why I put here as a unicorn. So while that is ideal, right? If we want a data scientist, we want a data scientist or a person who is called a data scientist to have all these skills, but in general, humanly, it is not possible. I mean, some people may have some of the skills, albeit not at that level, right? If a guy is a statistician, he may not be a super duper software engineer because his programming skills may be limited. Likewise, if somebody is a super duper programmer, Python programmer especially, he may not be a great statistician. He may know some basics of statistics and so on, right? So to find somebody who's good at all of this is a little unrealistic. And I think that is where very often people confuse, and I think that causes some of these debates. And why is that? Because now, while everybody wants to be called a data scientist, but actually, strictly speaking, not everyone who is working in the data science area is doing everything, right? And we all understand that's in a way not possible. So that is where the whole argument or the whole debate stems from. Now, just to help, as I promised, let me play a small video, to again illustrate what people think about data scientists. So this is a slightly older video, and let me see. Yeah, this is the one. Is everyone able to see my screen, my YouTube video I'm about to show? Just confirm. I switched from PPT to, all right, okay, great, good, thanks. So this is, as you can see, it has a little humor, so please pay attention. And it's a little longer, about 6.5 minutes, but I will shorten it. I'm not playing right from the beginning in the interest of time, so that we don't have to play the entire thing. But there is a little bit of a humor here, and also it conveys, by the way, it is almost 6 years old, 2014. So during that time, what were people thinking about when they had a data scientist in mind? That's what is shown here. And this is how it has evolved, right? When the whole data science concept started, they had something in mind, who is a data scientist, and then we had this big data wave. So everybody thought a data scientist is a guy with all big data skills, and now we move towards machine learning and AI. So now a data scientist is somebody who has expected to have machine learning skills and so on, right? So let's watch this video a little. As I said, a little bit of humor as well. I'll start playing, and then we will go from there. Okay. In case you have issue with audio, let me know. Hopefully, you should be able to hear.
Our product is superior to theirs. Our price is much cheaper. Yet somehow they are destroying us in every market from here to Wichita. Any of you geniuses want to tell me why? Says here, they're using big data. They have an algorithm on their board. How come we're not using big data? All right, bottom line. You need to figure out how we get into the big data game. And you need to figure it out now. Or this place is going to come down with a hard case of turnover.
Would you relax, people? Harvard Business Review, April 2014, and I quote, The best way to get into the big data game is to hire a data scientist.
Yeah, but what is a data scientist, right? I mean, is it a mad scientist in a lab coat? What?
Not exactly. Data science has been called the sexiest job in tech. They don't come cheap, but they get the job done.
So what was your last data science project?
Military assignment. I'm not at liberty to discuss that.
This here you were working with lab rats.
Well, statistically speaking.
Lab rat?
Flexible schedule is a must. I do all my best work at night.
Look, we really have an urgent situation here.
Data science is an art form. I mean, you don't just tell Beethoven to write a song. The song comes when Beethoven is ready.
Beethoven's been dead for a while now, you know?
Whatever.
IBM, SAS, Oracle. What do they all have in common? I turned them down. Okay? They didn't meet my salary requirements.
No problem. You can write your own ticket here.
I have 3 Italian greyhounds. 3. Okay? They require a dog sitter and a nutritionist.
We'll add that to the contract.
I'm glad we understand each other.
Look, so we can produce results in real time, okay? Because listen, we have 10 marketing campaigns running. We need data in real time in order to test if we're effective.
Don't even worry about it, okay? I can get you your data within 3 months.
What?
Okay. Big data. And I mean big data. Billions and billions of data points, new esoteric forms of data. You got to factor that in. The data will speak when it's ready, not a moment sooner.
Bloodsuckers.
We need them. I may be able to negotiate out the dog nutritionist.
But we may not have 3 months.
I have a good feeling about this guy. If we just put our data in his hands, we'll be in good shape.
Let's just face it. They got us by the short hairs. If I did not know better, I think you knew I was going to spill the coffee.
I knew.
Predictive analytics. We've been modeling your behavior. We use big data to predict when we need to clean up your mess.
You use big data?
Sure, everybody in our company does. Power of the platform.
You have a data scientist?
We don't need one. Platform's got us covered.
Okay, in the interest of time, I'll just fast forward it a little, and they end up actually hiring that guy as a data scientist.
Words to live by. Analytical enterprise. If we want to win, we all have to think like a data scientist.
All right, so let's come back. So I think so at some point, people were thinking that big data is data science, and for people to a data scientist is somebody who has these big data skills and so on, right? So there is also a common myth, and this is where the whole thing is probably stemming. When somebody says do not democratize, what they mean is that a data scientist needs to be a mathematical genius, and that's the reason, right? We shouldn't allow everybody except only those who are very good at math. So this is another, I would say, myth to some extent, because there is some truth in it, but by and large it is. So we don't have to really be a mathematical genius to contribute to data science. This is another factor. As we move on, we will see. So I think data science also has 2 parts, and this is where a lot of people confuse, and that's another reason why some of these debates happen. There is a pure data science side of things, and there is an applied part of it. Pure data science is where people are, let's say, they do the research, they write papers, they create new algorithms, they create new models. I think some of you heard about GPT-3, which is a language model. Earlier to that, there was, of course, GPT-2 and BERT and so on. Now, to come up with those models, to create those models, to train those models, definitely you have to have very, very strong in-depth mathematical skills. You can't do if you don't have very strong mathematical skills, including linear algebra and so on and so forth. Statistics, of course, has to be there and so on, right? But the work there has, in a way, the quantum of work there is much less, and that's why it is restricted to a few people compared to the applied side of data science. What is applied data science? Applied data science is where you actually apply some of this research already what has been created. There are already a lot of algorithms created. There are models that have been created. How do you apply that to solve real life problems? And this is where a lot of work today is being done in the world, because remember, there are a lot of problems in the world, and we need, in a way, all hands on the deck, right? We need a lot of people to apply this and solve some of these problems. And in order to do that, in order to use or apply data science, you don't have to be a mathematical genius. You still need some basic understanding of math, but you don't have to be a mathematical genius, right? So this is sometimes some people don't get this part, and that's the reason, another reason why some of this debate happens. As you can see here, this is from KD Nuggets. There's a poll that was done. The skills that people have, that is on this side, on the x-axis, and the people that are, sorry, the skills that are wanted, if you see here, right? There is a big gap. These are the skills that are wanted, and not a lot of people have those skills, right? Deep learning, TensorFlow, NLP, Hadoop also to some extent, right? So, which means there is these are mostly more on the applied data science side of things, right? Let me take you through a little bit the process, and hopefully you will get an idea what is meant by applied data science. So when we are talking about a project, somebody's working on a data science project, right, to solve a problem. So this is the way the whole process works. This is the way the data is handled or processed or whatever you call that. So there is the data capture part, and there is the data is stored and cleansed, and then there is EDA, as we call it, exploratory data analysis and visualization. So this part on the top, almost 80% of the work still happens out here, because remember, data is not the data that we capture, the raw data is not clean, and it is not in the format in which an algorithm can take it usually, right? So a large part of the work needs to happen when you start a project. A large part of the work happens here, and this is where big data sits, right? If the data is huge and unstructured, then you need to use a big data platform. You need to use maybe Hadoop or some NoSQL database and so on. Prepare all the data and then do some visualization, then do some exploratory analysis. And this is where a bit of statistics is required, right? So we are not saying that you don't need any math at all. There is some math required at this level, okay? But I'll come to that. Does everyone have to be a mathematician here? Again, I'll come to that in just a bit, right? So 80% of the time and effort in a data science project is actually spent here, okay? And then, remember, we're talking about applied data science, right? When it comes to models and ML algorithms, ML or DL algorithms, again here, the algorithms are already existing. So people working on these projects, their job is not to create any new algorithm or to create any a new model per se, right? So their job is to use existing algorithms, but there are several algorithms, so they need to test it out, which is the most suitable one. And so their job is to try out the various algorithms and then train those models with this data, right? The data is already here. They have to. So this is more not not like an R&D job, right? So this is more an application developer kind of a job. And then of course, once that model is trained, then we actually right, we deploy that model, and then you have the decision or the application or AI as we call it, right? So these could be developing something like I'm sure all of you recognize this. What is this one? Anyone recognizes this piece here? Just making sure everyone is listening. How about this one? Yeah, that's right. Narendra Singh says Alexa and Sophia, exactly. Very good. So, and this is a chatbot. So these are some of them, I'm just giving some examples. So these are some of the applications, right? Manifestation of AI and data science. So in order to achieve some of this, we have to do this kind of, the data has to go through this kind of a process. And here, as you can see, one person will obviously not do the whole thing, right? So there will be a group of people, some specialists in statistics, and they are probably the people who are looking at the data. They need to perform any outlier analysis, whether the data is having the normal distribution or is it skewed. Somebody has to write the code to maybe clean the data if there are some missing values, right? So all that statistical skills are required in order to do that entire thing. Statistical skills, probability, programming, Python programming is the most common skill required, and so on, right? So by the way, just wanted to, since we were talking about applications of AI and data science, just recently I came across this post on in Washington, an article. China, as you all know, China is way ahead in AI, right? And they have actually they have mastered the art of facial recognition. They don't even use credit cards in some cities. They don't accept, in fact. Only facial recognition. You take the stuff, show your face with a smile, so you pay with a smile, right? Now these Chinese have come up with a facial recognition for cows. Can you believe that? First, I couldn't believe, actually, unless it was if it was not in Washington Post, I wouldn't have believed. But they are developing this facial recognition for cows. Anyway, but overall, I think this is a part of the entire dairy farming industry, looks like. So that was the context. I thought I'll just mention it. But coming back to our discussion, so what are the skills required to solve any large scale data science problem? You need, as I mentioned, you need some math, right? As a project, I'm talking about not a single person, but as a part of the entire project. The skills required, definitely math is required, because you need to, the moment you collect the data, you need to do some statistical analysis. You need to find out what are the outliers, are there any missing values, how do you fill the missing values. You need some probability related skills, and so on. Then you need skills to handle the data. And if it is large amount of data, you may need big data skills like Hadoop and Spark and so on. But if not, at least you should be able to query your data using SQL, or these could be CSV files, right? So definitely you need some data handling skills as a whole project team. Then you need some visualization skills. You put it on a dashboard, or charts or something like that. Maybe it could be your end output, or it could also be the intermediate stage. You want to check how your data is. This visualization could also mean showing like outlier box plot, right? So if you want to see how the outliers are, you can put up a box plot. So that also comes under visualization, right? And then obviously algorithms. If you want to do some machine learning, apply some machine learning or deep learning, you need knowledge of algorithms and skills of algorithms. Programming, definitely, and the most common programming language is Python. And so I will tell you in a little while, one of the first steps if you want to learn data science is Python programming, right? So Python is becoming like the gold standard. And of course, infrastructure, cloud, and this is by no means an exhaustive list. I just put down a few skills required. So this kind of right? If you want to execute a project like this, it is impossible for one person to possess all these skills, right? Of course, it would be like, as I said, that mythical beast. It would be lovely if one person has all these skills and then you can just run the entire project with this one person. But that is not possible. Right? So we need, as a project team, typically that's how in real life, that's how it works. So you have a project team, and it could be based on the scale of the project. It could be 10 members, 15, 20 members, and there will be specialists. So you will have one guy whose job is to do all the math. And so this could be within the team, he could be the math genius, right? So he's the guy go to for all the statistics and linear algebra, probability, and all that stuff. There will be one guy who is a super duper data analyst kind of thing. He can run all kinds of complicated queries to look at the data, find out what are the missing values, and so on. Then there will be one guy whose job is to put all these graphs and maybe create dashboards and so on. And then there will be another guy whose job is to find out what are the most suitable algorithms, whether this is based on the problem, whether this is a regression problem, is it a classification problem, and then decide which within those, again, areas, there are multiple algorithms. So for this given data, which algorithm makes sense, right? So there has to be one specialist there. And then of course there will be a few, at least, and in general, many of them may have programming skills as well, but there will be a couple of guys who are really specialized in programming. They can write all kinds of code. You give them a problem and they will solve it using the code. And then of course there will be people where you need to deploy. Finally, you need to deploy this somewhere, so you need to have a cloud and infrastructure people. Okay, so let's take a couple of examples and see how this whole thing works, right? All of you, I'm sure at least most of you would have seen a dashboard like this. Today, we are in the middle of a pandemic, COVID-19 pandemic. And it's actually, in a way, data science is coming to the rescue of this, because we don't have a vaccine, we don't have a cure as of today. The only thing we can do is track the cases, track the fatalities, and keep a check, and try to curb or curtail this disease, this pandemic, right? So in a way, data science is the solution as of today for this particular problem. And actually the whole world has come together. This has in a way united all of us. And can you imagine, everybody is feeding data to this John Hopkins dashboard, university dashboard, and they are collecting data from all the countries, and they are putting up this dashboard pretty much real time. This dashboard is, and imagine such a large scale project. In order to put something of this size together, they obviously need all kinds of skill sets here, right? And by the way, unfortunately, we are in third position here, right? It's not a very good situation, but yeah. So it is right. So we need all kinds of skills, not just math, but this was created with people with math skill, with Python skill, with web development skills, and so on and so forth. So when we say data science, there is a lot going on there. Not just the mathematics, or not just the statistics, right? So that's the important thing, and that is something that needs to be kept in mind, and that's some of the reason for some of these debates. I'll give you one more example. So that was one very complicated one, and a large scale project. Now let's say I have another a smaller problem to solve today. Right, and this has been, sentiment analysis has been there for quite some time. I used to work on it almost 10 years back when I was with IBM. And believe me, that time it was not as easy. But today, if I want to, let's say my problem that I want to solve today is to do some Twitter sentiment analysis, right? Real-time Twitter sentiment analysis. In those days, 10 years back, there were not a lot of APIs or algorithms that were readily available that we could use. we actually had to do a lot of, believe me, we had to do a lot of the math and all that, right? Today, you think that is required? Not really. I'll show you very quickly a demo where, so this is my, yeah. So this is my, can everyone confirm? You can see my code. I'm showing you some code in a Jupyter notebook. This is the environment. Yeah, okay, thank you. So this is Python. Obviously, you must have recognized this is Python code. And let's assume we want to fetch some tweets of anyone we can do, but just for the fun of it, let's say we want to fetch tweets of who else but Donald Trump, right? And we want to analyze, basically when we say sentiment analysis, what we typically do is get the tweets and say, overall, how many tweets are positive, how many are negative, and so on, right? So that's a broadly 3 categories, but then we can also come up with different classes, angry and petrified and so on, right? But broadly, they are like positive, negative, and neutral. So if I want to do something like this today, actually it is pretty straightforward. I have probably 50 to 60 lines of code, and I can do it. And by the way, I want to run this live. Let me just run it live as I promised, right? We will have some demos. And so let's say I will I can provide any handle. And just so I have also given Narendra Modi here. So after Donald Trump, we can also try Narendra Modi's tweets. So what it has done is it fetched about 200 tweets, and that is also customizable. And each tweet has been given a polarity, right? So whether it is positive, negative, and then based on that, I have kind of put together a code to put a, this is visualization. This is the known as visualization. So here it shows that 77% of the tweets are neutral, 15% are positive, and 8% are negative. Now, let me also show you that these are actually live tweets. So let's take so this is a list of tweets, right? So the first one says Kenosha has been very quiet. So I think this is one of the areas where they're having trouble in the US. Maybe in case you're keeping track, if you watch news, you probably have come across, right? There is unrest going on there, right? So you see here, this is the live Twitter page. I will just refresh it. And this is the first tweet that is available here. Kenosha has been very quiet, right? And that is what we have captured. The second one, I think it's just a video, so that's why there is no text here. The third one is, I can't even describe the sinking feeling. So this is what, I can't even describe the sinking feeling, right? And so on. So just demonstrating that this is a really real-time sentiment or Twitter sentiment analysis. Now, how difficult is it today? With just 50 lines of code, I was able to do it. Did I have to use a lot of my math skills? Not really, because all of it is in the form of API. And therefore, what is the primary skill required here is Python programming, right? And I was able to solve a reasonably, I wouldn't say this is a very easy problem, right? This is a sentiment analysis is a reasonably complicated problem, but I was able to solve it using one of my skills, which is Python programming, right? And since I promised, let me also run it for Narendra Modi just very quickly. So if we take this, and so we will probably not go to his Twitter page, but we'll just see how what is the sentiment here. Yeah, so you can see here he has much more positive tweets. 43% is positive, only 4% negative, and fairly good amount of neutral tweets, right? So inaugurating college and admin. Do I have his page? Yeah, of course I have his page as well. So you see here, inaugurating college admin building is the first tweet here, and then Government of India is making numerous efforts, and so on, right? So I think we can go back. So that was one more example of, what is the complexity and how much of math really is utilized and so on, right? So that's what I have shown you here. So in this particular example, I have only used these highlighted, pretty much highlighted skills out of all the skills that I have listed here. Mostly this was the one, programming. It was mostly 50 lines of code, a little bit of visualization. I displayed a couple of charts. In a way, this was unstructured data. So even though I did not use big data or anything like that, but there was a little bit of data as well, data handling as well, because we fetched the data and put it, even though I did not elaborate the code, but that's what we did. We fetched the data. It was more like a data frame, and we had to then feed it to in a way the algorithm. So that's the that's a very another good example which says that really you don't have to be a super duper mathematician to do some of these tasks, no, right? So but of course the problem also is that in the industry everybody is calling themselves or wants to call themselves a data scientist, and companies are also, every position, any task they they are looking for, any job description they're looking for, in general they're just calling it data scientist, and therefore that is also causing a lot of problems or confusion. But NASSCOM actually has in a way separated out the job roles. So you can see here what are the different kinds of roles. Sometimes we combine all of this into data scientists, but in reality, based on the task that a person is doing, there are different kinds of role. There is an ML engineer, this is the guy who knows about machine learning. There is a data scientist here, as you can see here, right? And then there is data quality analyst, BI analyst, data architect, and so on. So there are actually different roles, and which are today very often bundled together at data scientist. And that is where a lot of confusion happens, that, okay, if a person doesn't have math background or is not very good at math, he cannot become a data scientist. Not really, because as I said, there's a different role there, right? These are some of the jargon I thought I'll just put forward here. This could be one of your takeaways. So AI, I think all of you probably would have heard about. AI, ML, DL, this is again within the data science community most talked about. Artificial intelligence, machine learning, deep learning. And then neural networks is again one of the key areas, especially for deep learning. These two go together hand in hand, deep learning and neural networks. And then within AI, these are the two main components, image recognition and speech recognition today. And speech recognition in turn uses text analytics and NLP. In my last in my last webinar, conversational AI, I talked about this, right? And in case some of you missed that, you can find the recording on our YouTube channel. And then of course, big data. By now, big data is about 5, 6 or 10 years back, big data there was a huge, in a way, a buzz around big data, just like we have today around data science and AI and so on. It's still there in the sense that this is massively used. There is huge demand for skills, by the way, in this space, but the buzz has in a way reduced and subsided rather, right? Then structured and unstructured data, it's a part of big data. EDA, I just talked about, exploratory data analysis and data visualization. These two go hand in hand. And then of course, GPUs are used for training these neural nets, right? So training these neural nets is not very easy. They are very compute intensive, and using GPU or graphic processing unit or graphical processing unit like CPU. It's an extension of CPU in a way. It helps in expediting the training. Google Colab is a free environment for, just like Jupyter Notebook I showed you. It's on the cloud, and anybody can access it free of cost. What are the other, not buzzwords, but these are the tools that are used. What are some of the tools? Again, as I promised, these are some of your takeaways. Programming languages perspective, Python is by far the most popular. In a way, I would we call this as now become the gold standard for writing code. R was there 5, 6, 7, 8 years back. Probably R made a good comeback. R was there for very long, by the way. But with R Studio, it made a good comeback. But then now Python is in a way the most suited and preferred programming language. By the way, there are a few others coming up. Julia is another one, if some of you have heard about it. But as of today, if you want to start in data science, I think you should stick to or start with Python. There are some Python libraries, as I've shown you. Some of it I used in the previous code. Pandas is for handling data. NumPy, SciPy, Matplotlib for graphics or visualization that we do. OpenCV is for computer vision. And this is the one for machine learning. So these libraries, as I said, right? So this kind of helps in let's say, hiding the complexity. right? So that is these are like wrappers. There are functions provided, so you don't have to really implement those algorithms. These are algorithms are already implemented here. Of course, if you are interested, you can learn about them, and it helps to understand the algorithms before you actually apply. But it is not like that's a must, right? And for understanding those algorithms, of course, you need math, and that is where, as I said, that's the debate. Deep learning libraries are TensorFlow is again the most common one. And then of course most popular rather, and then of course PyTorch. They both, in a way, there is like a healthy competition between these two, right? So this is like India-Pakistan cricket match. So there are followers of TensorFlow, there are followers of PyTorch, and there is a healthy competition. Sometimes TensorFlow goes ahead, once in a while PyTorch goes ahead. But by and large, I think TensorFlow has maintained its lead. There are a few others like Theano, Keras, and Cafe. Development environment, again, there are different people have different preferences. My preferred environment, of course, is Jupyter Notebook. Very good for learning, training, and initial parts. But later on, I think there are others which are in production. There are other environments like PyCharm and Spider, which are probably a little bit more, especially expediting development. It is probably better. But Jupyter Notebook is very good when you're learning and training purpose. I think these are very good, right? And then Anaconda is actually a part of the environment, but this is just for primarily for distribution purpose. For Python distribution, we use Anaconda. And a very powerful, popular visualization tool is Tableau. Some of you would have already heard about it. It is by far the best visualization tool, but it is also among all of these, right? Everything else is open source. This is the only tool which is commercial. There are some free versions of it, but in general, this is a commercial tool. But otherwise, if people can afford it, and that's what most companies do. This is a very good tool, Tableau, right? So that's in terms of the what are some of the tools that we use and so on. So there is a question. Can you all hear me? I get a notice that my internet connection is a little. Okay. So, okay, is it better now? It says it is better now, so I'm hoping you can hear me better. But in case you're having difficulty, let me know. I can switch over. I have one more Wi-Fi connection. So, all right, okay, thank you. So Narendra Singh has a question. Can we not use TensorFlow for machine learning? Is there anything? Absolutely. So, TensorFlow you can use for machine learning, but the overheads, it may not be worth it. My suggestion, right? Again, while you can use it, but it is not a good practice. Machine learning, you use scikit-learn, and TensorFlow, for deep learning, you use TensorFlow. While nothing prevents you or stops you from using TensorFlow for machine learning, but it is, in my opinion, it is overkill to use deep learning. This is good when you have when you use neural networks, right? That's where TensorFlow gives the best results. Okay, so that's I hope that answers your question, Narendra Singh. Okay, so how do you go about, and we are almost nearing the end of the session. So first thing obviously is, in case some of you are new, I'm assuming some of you already have dabbled with data science, but in case some of you are new and wanting to learn, obviously the first thing is the desire. Now that first thing, I wanted you all to break that myth that, okay, you have to be a super duper mathematician, mathematical genius to work in data science. No, that's not true. I hope that has been cleared. Then the next step is, okay, do you have a desire to learn data science? And right, you need to develop that desire and attitude. Otherwise, of course, you won't be able to learn. Okay, Rikin has in how do we need to learn Python? Yeah, so that's what. So I didn't get the whole thing. You're saying in how deep, in how depth, that's what you're talking about. Okay, how deep Python? Okay, yeah, that's a good question. I'll come to that. So the first thing obviously is to learn Python. Now the depth of Python, again, Python is also very elaborate programming language. So there is something known as Python for data science, right? So you need to, first step is to understand the environment, understand the syntax, the control flow, for example, the for loops, while loops, if conditions, and all that. So that's the basic of Python you need to learn. Beyond that, you don't have to go towards building applications like using Flask and things like that. The UI part is not really required. But what you need to do is Python then has a lot of libraries which are relevant for data science. So that is what you need to do. So you need to get hold of these libraries like I mentioned here, right? So you need to get hold of pandas, NumPy, and so on. Then this will help in pandas, NumPy, matplotlib, and SciPy to some extent will help in the EDA part of things, right? If you remember in my data flow, I showed the data handling part will be done here. And then if you want to go to the machine learning part, you need to get hold of the scikit-learn library and so on, right? Now, all that may be doing in a self-learning mode may be a little difficult. So I'm just giving you step-by-step how to do it. In case you, so first is to learn Python, at least the basics, get hold of the syntax if you're new to Python. And also it's a very easy language to learn, by the way. And if you already know another programming language like Java, it is even easier. Then you need to learn the basics of data handling, like how to handle CSV files and SQL and so on. Brush up some of the math because this is required when you're learning. I think some basics of math will be required, like probability matrices. Otherwise, some of the concepts you may not be able to understand fully. Again, as I said, you don't have to be a super duper genius, right? This is a class 10 level or +2 level math we are talking about, probability matrices and so on. And then you need to decide whether you want to go towards the deep learning, machine learning side of things, which requires a good amount of comfort at programming, or you want to stay towards the data handling part, right? You remember the top I was talking about. So there is a lot of demand in terms of jobs also in what is known as data engineering. So you can focus on this area. Learning Python would still be a good idea because even here some amount of Python programming is required, but not in depth, right? So, but if you enjoy programming, then this may be a good area. You can also, if you're completely new, you can test the waters whether you are, in a way, inclined towards learning this or not. So go to YouTube, look at some videos on data science. There are a lot of free stuff available. That's the best way to start. And once you pick up some stuff, you can practice. There are some areas like Google, participating in Google competition and hackathons, but sometimes people may feel you're not yet at that level to do that. Then you might want to take up, because self-learning, you can only do that much. So you can, consider taking up a training program like the one that we are offering, right? So that is, and we offer this Intel PGTDS program, which is a 6 months program. It's completely online. It's about 200 hours of content, including online live sessions. There are about 80 to 90 hours of live sessions over the weekends. That's the one here, Saturday, Sunday. And there is a lot of content on LMS, which is for self-learning, like videos and so on. It's very practical oriented, hands-on oriented. There are case studies, projects, mini projects, assignments, and it ends up with a capstone project. Right? If you're interested, just get in touch. And this is the curriculum. I think you can also look up our website. Fairly detailed for 6 months. We are running out of time, so let me just cover one more part, important part, before I answer. Saranya, I will definitely answer your question. Please hold on. So the other important part is this program is in association with Intel, and we partnered with Intel because Intel has a very, I think many of you would have seen, Intel has a strong presence in the AI data science area, and Intel One API. Of course, before that, I think it has at all layers, right? Starting from hardware, Intel has is developing like a AI chip, and then it goes all the way to libraries and toolkits and solutions, readily available solutions, right? So all the way from bottom all the way up. But of late, Intel's One API is now available. It's actually no longer beta. I should update this slide. And the Intel is actually popularizing with its customers. And this is a platform. It offers a lot of improvement to the basic code or basic libraries that are available. What do we mean by that? Intel has its own distribution of Python. So this expedites, especially for data science, right? The performance is very important. If you're training a model, you want to speed up the training process. So if you use one API, it helps there. Intel also has its own distribution of TensorFlow, right? So, and again, if you're doing something like training a model for image recognition, even on a GPU, sometimes this might take very long if your data is large. In fact, some of the models even take like 24 hours, 48 hours, right? If there is large amount of data, it can really take a lot of time. But if you use Intel One API, that's where I think it offers a lot of advantages. And there are at different levels, as I said, it starts with TensorFlow, and then OpenVINO is available. This is also at the inference level, which means that edge computing, as we call it, right? So this is a device which you can plug it to your laptop, and inference will be much faster compared to either on a regular CPU or even on a GPU. So these are some benchmarks. As you can see, there is one of the important libraries called Intel DAL. So if you use that versus the regular scikit-learn KNN, right? So what is the speed up? As you can see, it is almost 6 times faster if you're using Intel DAL, which is the Intel distribution of some of these libraries. Okay, so visit this website, One API website. I think you can get a lot more details there. Now, I've pretty much covered what I wanted to cover, and it is, I think, almost 5 o'clock. But for those who have some more questions, I think let me now take up those questions, and I'm open to more questions. If you have any more questions, please put them in here. So Saranya's question is, if already the application in .NET, we have to implement data science, in that condition, Python supports the environment. If the project is $1 million investment, how can we source like Python? We do open source like Python. Okay, so when you say a project in .NET, so I'm assuming the data, it's not the data science project which is in .NET. So it is also possible that you already implement it in .NET. So then you don't really have to move it to Python. No, that's not what we are saying here. What we are saying here is, if somebody is starting a new project, wanting to learn data science, we are talking about that. So don't get me wrong. While Python is the most commonly used programming language for data science, that doesn't mean that you can't do a data science project using Java or .NET for that matter, right? C# or whichever language you're using. So I hope that answers your question. So if your project is already in .NET, you don't have to move it to Python, which means you're already. But the thing is, as I said, industry standard is Python. Right? Any new project that starts in data science, they don't use Java or .NET. They actually use Python. Okay, so that's the idea. So if there is already something is existing .NET, obviously it doesn't make sense to, as you rightly said, if it's a $1 million investment, nobody would scrap that and to start with Python. But if a new project is starting, I think that's where we are talking about Python. Good. Any other questions? Otherwise, okay. Rikin says, what's the difference between these 3 terms? Data science, analyst, analysis. Okay. So and their roles. Yeah. So as I said, Rikin, there is some difference, but these are not exactly compartmentalized. So for example, somebody doing data science doesn't mean he doesn't do any data analysis at all. Or somebody who is a data analyst doesn't mean he's not a data scientist at all, right? So there is a good amount of overlap, and in my opinion, these are all just some names. My suggestion is, don't go too much by these names. If there is let's say a job title, let's say you're looking for a job and the job title says data analyst, the best thing is to ask for the job description. That will exactly tell you what this job entails. Is it doing reporting? Is it analyzing some raw data? Is it applying machine learning? Is it applying statistics? Right? So, because to be very honest and to be very frank, nobody has an answer to this, because there is really no one entity controlling all these terms and terminologies. Each organization uses these in their own way. As I've shown, NASSCOM is trying to do some standardization, but I don't think everybody is compelled to follow that. So in my opinion, don't go by these names, by the names of the roles. If somebody is offering a job, for example, if that is the context, ask for the job description and find out what the job entails, and then you decide. And no matter what they call you, they may call you data scientist for all you know, right? Because as I said, that's the most fancy job title everybody is looking for. But then you need to find out what exactly the job entails, okay? Yeah, again, your question, next question is business analysts come under data science. It can come under data science. It may not, again, as I said, right? Today, data science is like an all-encompassing terminology, right? When we say data science, everything related to data comes under that. So it's very difficult, but a particular organization may have their own way of giving these right titles and roles. So my suggestion is don't go by these names, right? So avoid going and getting confused by these names and terminologies. Go strictly by what you're interested in, and then if there is a job offer there, yeah, just check for the job description and what it entails. Okay. I think I'll take maybe two more questions since we are running out of time, and then we can wind up. Is it necessary to belong from engineering background? Most of the job description requirement. Yeah, okay, very good question, and I was hoping and I was wondering why nobody asked this. So there are two aspects here. For learning data science, do you have to be an engineer? No. The answer is very straightforward, very easy. No. For learning data science, no. Now, for a job, this is purely the the organization's rules and regulations. You're very right. Most of the organizations in their requirement, they say you have to be an engineer, right? That doesn't mean that non-engineers cannot learn data science, but it is more of their operational issue. Remember, and keep in mind, I've been in the industry and I've been in hiring as well. I've hired at least several hundreds of people over my 30 years of career in big organizations like SAP and IBM. And I've also hired for my own organization, my startup, right? The rules were completely different. Obviously, SAPs and IBMs, since there are so many engineers available, they can afford to put a filter criteria like that, saying that you have to be, because there are so many applications just from engineering graduates they will get, right? And it is more an operational thing. It's not that because they think that non-engineers can't do this job, but if they open it to everybody and if they get millions of CVs, they cannot handle it. That's humanly not possible. That is the primary reason, right? Whereas when I was hiring for my own organization, of course, I also believe that there are some people who believe that you have to be an engineer, but I also believe you don't have to be an engineer. So I was applying my principles as well. I was not just talking, but I was also implementing that. I hired quite a few non-engineers, not only non-engineers, non-science background graduates, BComs and I don't think arts, but mostly BComs and science, right? So what's the reason? Obviously, for us as a startup, we are open to, that's number one, we are open to anybody who wants to apply. Number two, I personally also feel that you don't have to be an engineer, right? So I hope that answers. It was a little longish explanation because it goes back to my the rest of the presentation as well. That's the reason, but I hope that answers. So these are two different things. Getting a job and learning are kind of two different. Thank you. Okay. So I think with that, we come to the end of our session. Thank you all very much. Really appreciate attending this session. So
Thank you, Mohan sir. I think it was a very interesting session.
thank you.
Right from understanding the jargons and the terminologies used in the current market to a very complex example which you gave about the John Hopkins University and the data around COVID to a pretty straightforward 50-line code to understand the sentiment analysis. I think it was a wonderful session. Everyone attending this session, you can once again connect with us at Times TSW. We already have a collaborated program for data science along with Intel, which is currently going on, and the admissions are open. I'm posting the link on the group chat for the benefit of everyone. If you're interested, you should go through this link and understand the topics and the models which we are going to teach, and have one of our advisors connect with you for a detailed explanation. So thank you, sir, and thank you everyone once again. Please stay safe. Thanks a lot.